Hello student, today we see the different methods of the X-ray diffraction. There are four different methods for the XRD. First one is the Louis photographic method, then Bragg X-ray spectrometer method, third one is the rotating crystal method, and the last one is the powder crystal method. We see one by one. First method is the Louis method, Love method. There are two methods of the Love. First one is the transmission method, and the second one is the back reflection method. We see first transmission method. This is the equipment for the Love transmission method. There is a X-ray beam passed from the crystal sample. There is a center in that tube. There is a crystal of sample. When we pass the incident radiation of the X-ray on that sample, the radiation will be diffracted. There is a film to record the diffraction pattern. This is the diffraction pattern of the single crystal. This is the equipment for the Louis transmission method. Now we see the instrumentation. There is A is the source of X-ray. This A is the source of X-ray. Then B is the pinhole collimator. This B is the pinhole collimator. Then when X-ray obtained from A are allowed to pass through this pinhole collimator, a fine pencil of X-ray is obtained because of that pinhole collimator. Then C is a crystal whose internal structure is to be investigated. C is the sample crystal ज्याचं आपल्याला इंटरनल स्ट्रक्चर फाइंड आउट करायचं आहे. अँड द D is a film arranged on a rigid base. This is the D. D is a film arranged on a rigid base, and this film provided with beam stop to prevent the direct beam from causing excessive fogging of the film. The X-ray after passing through crystal are diffracted and recorded on a photographic plate. There is a Love pattern of a simple cubic system. This is the simple pattern. How there is some spot are formed when X-ray beam is passed along the axis of symmetry of the crystal. The Love pattern would contain a series of spots whose loci are ellipses which pass through the central image made by the X-ray beam. This Love pattern can be used to orient crystal for solid state experiment. Let us consider the case of crystal with four-fold axis of symmetry and which is oriented with the axis parallel to the beam. Beamच्या parallel. Each reflecting beam then select a wavelength satisfying the Bragg equation from the incident X-ray beam, and the Love pattern obtained in this case shows the four-fold symmetry. This Love method is most suitable for the investigation of the prepared orientation sheets or fibers, particularly if the information is confined to the lower diffraction angle. Also, this method used in the determination of the symmetry of the single crystal. Then the second method of the Love is the back reflection method. Back reflection method provides similar information as the transmission method. This method is only method for the investigation of the large and thick specimens. There is an instrument or equipment for the back reflection method. Here also collimator, then film cassette, specimen, and the beam stop. When incident radiations are passed from the collimator, then they are falls on the specimen, and there is a one beam stop, and we get the crystal structure by this back reflection method. There is a main disadvantages of Love method, that is the big crystal is required, and furthermore there is a uncertainty in the significance due to unhomogeneous nature of the X-ray. This is the main disadvantage of the Lau method. Then the second method is the Bragg X-ray spectrometer method. This is the second method of the X-ray diffraction method, that is Bragg X-ray spectrometer method. There is a instrumentation or the equipment for the Bragg's X-ray spectrometer. Bragg devised a spectrometer to measure the intensity of the X-ray beam, and this method is based on the Bragg's law, that is n lambda is equal to 2d sin theta. See, there is a instrumentation for the Bragg's X-ray spectrometer. Instrument is same as the X-ray diffraction method or the X-ray spectroscopy, that is high voltage, that is filament heating circuit, which heated this cathode. Then this cathode passes electrons towards the anode. Then there is a, when heating of because of this electron, this X-ray source, X-ray radiation source heated, and which transmit or the radiate the X-ray radiation or the incident radiation. Then there is a one beryllium window. From that beryllium window, this radiation pass towards the collimator. Then from collimator, narrow beam of the X-ray is passed towards the monochromator. Then monochromatic lights is falls on the sample, and when this monochromatic light or the X-ray radiation falls on the sample, these radiations are the diffracted with glancing angle theta. There is a PB slit, then ionization chamber, then this is the methyl bromide, and the galvanometer. There is a galvanometer. These reflected X-ray radiations pass towards the galvanometer and then are recorded. X-ray are allowed to fall on the X-ray crystal surface, and crystal is rotated, so X-rays are reflected from various crystal plane. There is various crystal planes are formed when the X-ray are allowed to fall on the crystal surface. According to the Bragg's law, n is the integer, then lambda is the wavelength of the X-ray beam, and d is the distance between the crystal plane, and the theta is the angle of incident of the X-ray beam. For any given crystal, कोणता पण crystal घ्या, d is a constant. d म्हणजे distance between the crystal plane, and in any crystals this d is a constant. Hence the theta also constant, as in n lambda, and therefore if n is varies असेल तर लॅम्बडा तिथे चेंज होतो. इफ n varies, there is a corresponding change in the lambda, that is the wavelength. n varies म्हणजे n काय असेल, 1 असेल, 2 असेल, 3 असेल किंवा 4 असेल. n व्हॅरीज झाला त्याप्रमाणे लॅम्बडासुद्धा तिथे व्हॅरिएबल असतो. The next here example is given in following figure. This is the crystal plane. Incident radiation falls on that crystal plane 1, 2, 3. There is a 3 planes. D is the interplanar distance of that 3 planes. On the first line, on the first plane, incident radiation falls. Then on the second plane also incident radiation falls, and also on the third plane or third line incident radiation also falls. That is n is equal to 1, n is equal to 2, n is equal to 3, and there is a 3 theta angles are the form. Here graph is given for that 3 lines, that is n is equal to 1, n is equal to 2, and n is equal to theta. And for that glancing angle is the theta 1, theta 2, and the theta 3. There is a intensity decreases when n is increases. Now we see the intense reflections are measured, and the glancing angle theta of each intense reflection is recorded. D is equal to n lambda divided by the 2 sin theta. When we calculate the D, if n is equal to 1, then D is equal to lambda divided by 2 sin theta. When n is equal to 2, then the d is equal to 2 lambda divided by the 2 sin theta, and when n is equal to 3, then d is equal to 3 lambda divided by the 2 sin theta. Then we see the calculated ratio of the different crystal lattice. For simple cubic lattice असेल, and then d1 0 0, d1 1 0, d1 1, then the ratio is 1 as to 1 by root 2 as to 1 by root 3, and their simple form is the 1 as to 0.707 as to 0.577. This is for the simple cubic system or lattice. Then for the face centered cubic system, then the d1 0 0, then d1 1 0, then d1 1 1. For that the 1 is 1 as to 1 by root 2 as to 1 by root 3, and the simple form is the 1 as to 0.707 as to 1.1544 for the FCC crystal, and for the BCC is the D1 0 0 as D1 1 0 as D1 1 is 1 as to 1 by root 2 as to 1 by root 3, and the simple form is the 1 as to 1.411 as to 0.577. This is for the BCC. Now we see the one example. For example, NaCl crystal. We take the one example. NaCl crystal. For the maximum intensity reflection, the glancing angle are 5.9 degree, 8.4 degree and 5.20 degree for 100, 110 and the 111 phases respectively. For first order reflection, thus D100 kiti 5.9 degree, D110 kiti 8.4 degree and D111 is 5.20 degree. Then therefore D100 as to D110 as to D11 is equal to 1 point sin 5.9. 100 साठी किती 5.9. Then as to 1 divided by sin 8.4 as to 1 divided by sin 5.20. जर त्याचा साइन बघितला तर this is for sin 5.9 is 0.1028, for sin 8.4 is 0.146 and for sin 5.2 is a 0.0906. To obtain a ratio 1, पहिला रेशो किती आहे तिघांमध्ये पण 1, देअरफॉर या तिघांना कशाने मल्टिप्लाय करायला लागणार आहे तर 0.1028 टू ऑब्टेन द रेशो 1 बाय मल्टिप्लाइंग टू ऑल धीज 0.1028 is equal to 1 as to 0.704 as to 1.155 is equal to 1.1 as to 1.1 divided by 1 divided by root 2 as to 1 divided by root 3. Therefore, the simple form is same as the FCC, and therefore NaCl crystal as a FCC lattice. Then now we see the third method is the rotating crystal method. A rotating crystal method was developed by the Siebold in the 1990s. There is a instrumentation for the rotating crystal method. This X-ray source for the X-ray radiation, then collimating system. By that collimating system, the narrow X-ray beam is passed towards the crystal, and then these radiations, X-ray radiation, when falls on the crystal, these are diffracted with various directions. These X-ray are generated in X-ray tube, and then beam is made monochromatic by a filter. Then this beam is allowed to pass through the collimator. From this collimator, the X-ray beam is made to fall on the crystal mounted on a shaft which can be rotated by the small rotation. Then this shaft is moved to put the crystal into slow rotation about a fixed axis, and this causes the value of theta satisfies the Bragg's relation, that is the n value that change होतात. According to that n value, this lambda value also changes. Each plane will produce a spot on the photographic plate and then take the photograph of the diffraction pattern upon the photographic plate to X-ray beam, and we can take photograph in two ways. There are two ways for take the photographs of that X-ray diffraction pattern. One is the complete rotation method and another is the oscillation method. In complete rotation method, there a series of complete revolutions are the occurs, and it is observed that each set of planes in the crystal diffracts 4 times during the rotation. These 4 diffracted beams are distributed into the rectangular pattern about the central point of the photograph. This is the complete rotation method, and the another one is the oscillation method. One more major difference between that two methods is that the crystal is oscillated through an angle of the 15 degree or 20 degree in the oscillation method, and the photographic plate is also moved back and forth with the same period as that of the rotation. जसं रोटेशन होणार तसं ती फोटोग्राफिक प्लेट मूव होणार in the direction of back and the forth. The position of the spot on the plate indicates the orientation of the crystal at which the spot was formed. Then we see the last method of the XRD is the powder crystal method. In that the powder form मध्ये crystal आपण इथे वापरतो for the XRD. In powder crystal method, the crystal sample need not be taken in large quantity but as little as the 1 milligram as sufficient. 1 milligram sample पण तिथे crystal structure find out करण्यासाठी sufficient असतो. The powder method was devised independently by the Debye and the Scherer in Germany and by Hull in America at about the same times. There is a instrumentation for the powder crystal method. In powder crystal method, this is the instrumentation diagram for the powder crystal method. A is a source of X-ray which can be made monochromatic by a filter. This is not shown. This filter then allow this X-ray beam to fall on the powder specimen P through the slits S1 and S2. The function of the slits to get the narrow pencil of the X-ray. Slit इथे कसलं काम करणार तर कॉलिमीटर. In X-ray spectrometer we get the narrow beam by using the collimator. Here S1 and S2 slits are used to get the narrow beam of the X-ray radiation. This fine powder struck on here by means of gum is suspended vertically in the axis of the cylindrical camera. When this X-ray radiation passes from the slit, they are fall on the crystal and they get the diffracted around that vertical axis or the in the circle. The X-ray after falling on the powder passes out of the camera through a cut in the film so as to minimize the fogging produced by the scattering of the direct beam. This is the instrumentation for the powder crystal method. This powder crystal method is most useful for the cubic crystal and for determining the complex structure of metals and alloys. However, their structure could not be revealed by the earlier study. This method is also useful to make the distinction between the allotropic modification of the same substance. Today we stop here. In next lecture we see the application of the X-ray diffraction method.